Hi, I am Pham from San Jose State University. I am presenting the design and development of an exercise bike power generator. The objective of this project is to design a renewable energy source based around an exercise bike power generator. This project harnesses the mechanical energy of a machine and convert it to electrical energy using a generator-based system. The exercise bike will be attached to the shaft of the generator. The produced electrical energy is used in charging mobile devices, tablets, or powering a TV or computer while exercising. This type of electrical energy generation will help minimizing environmental impact and preserve the environment by reducing the emission of carbon dioxide to the atmosphere. Ideally, the system will be able to generate electricity without changing the footprint of the exercise bike or the user experience. Energy harvesting solutions for exercise machines is not a novel idea, and few companies have already provided machines which are equipped with additional system generating power. These include, for example, Sport Arts Fitness, ReRef, the Green Revolution, and Resource Fitness. However, the commercially available power generating exercise equipments are pretty expensive, ranging from anywhere from $3,000 to well over $10,000. In order to overcome these limitations, this project aims to produce an exercise machine with the option of producing power in a cost-effective manner.
An important step in the project was to develop a functional model for the product. The functional model was developed in two stages. First, the black box model was determined for the overall function. Second, the function tree was created to show the breakdown of the overall function into detailed sub-functions. Functional modeling is an excellent tool for understanding and creating new designs.
This design utilized friction drive of the spin bike flywheel to transmit torque and rotate the electric motor to generate electricity. Friction drive possess desired performance attributes that pertain to unique operating principles. These attributes include high mechanical efficiency, minimal backlash, low noise, and vibration with high speed capability. The power density of a friction drive can be very high when operated at elevated speeds. These performance features, in conjunction with its inherent manufacturing simplicity, make friction drive a suitable candidate for this application. In addition, friction drive is a more cost-effective alternative to conventional gear drive. The nice thing about friction drive are that they are mechanically safe and are extremely easy to assemble. This figure shows the cap model of the overall system. We have a stationary bike with an 18-inch flywheel. The motor assembly is attached to the bike frame, which then attached to this flywheel. When we have this flywheel rotate, it also rotates the mainboard wheel, which is in turn rotate the motor using friction drive. The electricity generated by the motor then is sent to this control box, which has a three-way bridge rectifier. The three-way bridge rectifier converts AC to DC in a usable voltage range. To be able to fabricate a physical model, there's some slight modification to the bike frame that need to be done. So we cut out this two slot here to avoid the interference with the motor assembly. The mainboard wheel then is kept from slipping by using a elastic bungee cord. Um, and we have a harness that connects from the motor to this control box. The spin pipe power generator was placed in the laboratory near campus. More than 10 students participated in testing out the system. All key data parameters were recorded, such as exercise duration, input calorie, output voltage and current, watts produced, and device percentage charge. It is observed that the USB chargers always produce a constant output of 13 watts. Measurements were taken for every 1 volt output increment from 9 volt to 15 volt. If the voltage is increased, the current draw will decrease so that the total output is always around 13 watts. The charging rate will be the same even though the pedaling speed is varied. We also use a digital tachometer is used to record the rotational speed of the flywheel, which is used to calculate the rotational speed of the motor. Taking the RPM value of the motor and compare with the recorded voltage output. This figure shows the result voltage generated versus the motor RPM. Theoretically, if we take a 140 kV motor rating multiplied by 12 volt, we should have a value of 1680 RPM. That means to be able to generate 12 volt, the motor should spin at a speed of 1680 RPM. In reality, the recorded value at 12 volt is 1972 RPM. This is expected due to some energy loss in the motor and the three-phase bridge rectifier. In conclusion, today energy crisis has become a problem all over the world. One has to look into alternate renewable energy resources. One such alternate renewable resource, human power generation, is presented in this presentation. The spin bike power generator was successfully designed and a full functional prototype was built and tested. The system successfully charges multiple mobile devices, battery bank, as well as powering a home appliance such as a 55-inch TV and a tabletop electric fan.